Welcome to the Thoughtworks Technology Radar sneak peek webinar, which is a bit of a mouthful. My name is Mike Mason, and I'm here with two of my colleagues, Zhamak Dehani and James Lewis, and I'll introduce them properly in a moment. I will say we welcome your questions and interaction with the audience, so please use the Q&A function for putting in your questions rather than the chat. It's easier for us to see things that are arriving in Q&A. We'll try and keep an eye on that as we go and maybe answer some questions if they're relevant to the topic at hand. And then we also have a more general Q&A session towards the end. I always find the Q&A some of the most fun pieces of the radar webinars because we really get to interact with people, and I'm sure we're all dying for as much interaction as we can get these days in our lives in the current situation. So this is a sneak peek for the Thoughtworks Technology Radar. The radar is a report that we have been publishing for 10 years now. This is the 10th anniversary of the Tech Radar. And what we do is we assess technologies and techniques and things that are happening in our world. We're a software consultancy, so we see a lot of organizations around the world. We look at the things that are going on in the industry, the stuff that our technologists and developers are able to use successfully, and then we try to give advice on those things. Our advice ranges from adopt through to hold. So something that's in the adopt ring, we think that that's really definitely the clear answer, the right choice for doing something, and we give some strong advice around that. Trial is things that we think are worth pursuing. We only ever put stuff in trial once we've used it in production. That's our litmus test for that. Assess is a list of things that kind of are on the horizon, maybe something that organizations should start to check out. And then hold is more of a kind of a cautionary note. That might be things that are new but not quite ready to be used. But more often these days, we actually use hold to sort of highlight something that we think is maybe a problem, maybe something that people are doing where we would give some different advice on that. And so we'll put that in hold. Let me try and do a proper introduction to the other folks who are on the call. So Zhamak is joining us from, I believe, San Francisco. And Zhamak, do you want to say a couple of words about yourself? We've got lots of words on the screen, but
yeah, I do. Okay, not so much. It's just like Mike and James, I'm a member of Tech Advisory Board, which produces this radar. So, and also I act as the technical director for North America West Coast clients. Both of these are very fantastic, I guess, vantage points to have to see the patterns and the problems that repeat and the solutions that are successful and not so successful. So excited to be here and sharing some of those with you.
We also have James. James, you want to say a couple of words?
Sure. Yeah, it was pointed out that I haven't updated my my bio on the website for about 8 years, I think. So this is very out of date now. So yeah, I've been in Thoughtworks nearly 15 years now. Before that, I spent time as a software developer. I've been a developer all that time. I guess these days I sort of tend to think of myself as a sort of coding architect. So I don't spend so much time on individual projects, but tend to be across projects and then advising exec teams on technology strategy and that kind of thing. So again, much like Zhamak, it's a great position to have an overview really of what's happening across our teams, specifically in the UK where I'm based.
And you also have me. I'm Global Head of Technology for Thoughtworks. I work with our CTO in a group that we call the Office of the CTO. I've been with the company 17 years now, maybe. So that's a benefit and a curse. I'm probably not qualified to work anywhere else. But again, working with the Office of the CTO, I do get a good vantage point across the company. And the three of us are part of the team that puts together the radar. That was actually super interesting this year because for the first time ever, we had to do a remote only collaboration in order to produce the radar. We might touch on that depending on what kinds of questions and discussions we get into today. But also next week when the radar actually launches, we have kind of a ton of content associated with the radar, including a really great podcast. I think it's really great, talking about how we did the remote radar. So look out for that as well. So the way the sneak peek works is the radar has a ton of stuff on it. And what we like to do is go through a few of the things that we thought were interesting and maybe talk about some specifics and also talk about kind of the larger storylines that arose when we talked about them. So the first one is going to be something that we call the data perspectives maturing and expanding. And I'm going to throw that over to my two co-presenters, I guess, to talk about that one.
Sure. I mean, as the title says, it's an obvious one, right? It's an obvious observation that we put as a theme here, that we're seeing, the tooling technology platforms in data management, big data management, or in data analytics or data science kind of expanding and maturing. There was an interesting kind of tweet showed up last night in my feed that TensorFlow just passed 100 million downloads, and only last month 10 millions of those were last month, which is an indication of the acceleration. But there are a few sub themes that I think worth talking about within this kind of mega theme of continuous maturity of an evolution of the data tooling. And the first one is really around a shift in how we think about architecture and organizational kind of structure that we need to manage the modern day big data problems, right? And by big data or the scale of data, I don't mean the volume of the data. We solved that problem a decade ago, right? We had distributed file systems, the whole Hadoop ecosystem to deal with volume. But what we mean by an evolution towards architecture for scale is the scale of the number of sources where the data comes from, right? The proliferation of the systems that are now generating data for use, the proliferation of use cases of how we use data. We've moved on from using data for some sort of analytical reports that quarterly gets updated and gives you a view of your business to COVID happened, respond, right? The behavior of your business is now changing on a daily basis. So you need kind of machine learning embedded in every function you do. So then what are some of these architectural changes that we see? Data mesh is one. It's not new on the radar. We actually put it last time on the radar, and it's an architectural pattern that tries to addresses the limitations that we observed with the prior architectural patterns for managing big data, right? So for decades, we've thought about, okay, the only way to get use out of our analytical data and build this machine learning analytics on top is that all of this data has to be in one place. That's been the dream of CIOs. Get the data out of my databases and put them in one place, and that's how we're going to get value from it. And what we saw is really a graveyard of failed, very, very expensive failed projects that really didn't return the expected value and return on that investment. So data mesh kind of challenges that centralized paradigm for managing big data, and it draws from principles that we've used for years in the operational database, operational architectures. James is on this call, and he kind of pioneered and led the conversation around microservices. I can't remember how long ago now, James.
Sorry about that.
Well, yeah, I mean, I kind of followed your footsteps to a degree, and trying to kind of apply that, the same kind of fundamental principles that we apply to microservices in the operational domain, and bring that to the big data and analytical space, and that those are essentially thinking about ownership and decomposition of your architecture around the concept of domain, the domains where the data gets generated or domains where the data gets used. And that's very different different from how we thought about decomposition of architecture. Traditionally, we thought about decomposition of the architecture around technology, big data space, right? Your ingestion technology or your warehouse technology or your lake technology. The architecture is like just go to any cloud provider data lake kind of architecture, that's what you see, a bunch of technology wired together. So data mesh kind of inverts that model. Also, for data to be really useful and easily used, it kind of moves from data being a byproduct of running your business, and then somebody else down the hall in the organization coming and running some ETLs and getting that data, thinking about data as a product. And we talk about a bunch of characteristics of what does it mean to be used, have the usability and affordances of a product. What does that mean for data? And to be honest, the technology for big data management, it still has a high barrier. Like, if any of you have tried to, set up a Spark cluster to just do some sort of a processing, distributed processing, there's still a very specialized niche kind of domain for data tooling. And that when we think about decentralization and democratization of like generation of the data, that bar kind of barrier to entry needs to lower, and that requires a platform thinking and creating, the next level, the next generation kind of data platforms that can serve, the teams that are creating the data products. And when you think about organizationally how to govern the data, that's a very different story in a decentralized world, right? Traditionally, you have your governance team and they kind of own and control your data warehouse or whatever your big data tooling is. And in this model, you require a very federated and perhaps automated way of governance. So those are the kind of underlying principles of data mesh. Why we put it again on the radar is just that we're working, we're seeing a very active interest and active kind of involvement. It was interesting that InfoQ for the first time included a big data kind of architecture on their architectural trends. They don't usually do that because there's not a cohesion or a kind of the operational world. The architectures have evolved quite a bit, but not in the data world. And it was interesting to see that in the architectural trends of 2020 on InfoQ. But what we've also learned is that, and you might ask, why is it still assessed? And sometimes these technologies kind of move, and it's really for two reasons. And we're not saying this is for wide adoption. And I guess we're saying, by saying this is assessed, it's still kind of, you need to be part of those lead adopters to adopt this paradigm. And the reason for it is, one, still the technology is quite awkward. Like, we haven't reached the maturity that you can write a few lines of Golang and then publish and distribute a container, and voila, you've got APIs that serve capability. We really haven't got the same level of maturity with data tooling to build this like kind of data nodes on the mesh. That's one. And then the other one is really data mesh is exposing the organizational limitations. We hear these, expressions by the executives that we want the 1,000 flowers bloom in our organization. We want to democratize data, and we want every citizen developer or citizen data scientist to use the data. But the reality of it is that when you look at it and go, okay, for that to happen, who owns the data? Is there a distributed ownership, long-term ownership of this kind of domain-oriented data products? There isn't. What are the OKRs or any incentive structure that allows organizations to kind of distributedly own and share this data? There aren't. So that's why it's still unassessed. So it's still work to be done.
I mean,
hey, Zhamak, sorry, go ahead, James.
Oh, no, I was just going to say that, for me, I think it's the sort of the logical extension of what we've been seeing with building systems for the last decade or more. It's I think when you first talked to me about this, Zhamak, I sort of described, I think I said, that data is the last refuge of the horizontal or tiered architecture. Everywhere else we've moved towards product lines, bounded context, business capabilities, thinking in terms of those sort of structures, domain terms, but still with data, it was very, very technical. So I think this is great. This is a really exciting architectural style. The other thing is, and I think this is related to talking with some execs recently, specifically a CTO, and they were sort of saying, well, this is a really, really exciting idea, and we've experienced all the problems described in the article you wrote, Zhamak, on Martin Fowler's side. But also, it sounds like it's a big investment, and I think that's another thing as well. It's very difficult. If 5 years ago you went and said, hey, these data lakes, we need $30 million to build a new data lake or whatever it is, or sorry, that's one Oracle server, isn't it? We need $400 million or whatever it is to build a data lake, and then 5 years later you're going to go back to your board and say, you know, we're going to do this data mesh thing now. So it is nuanced now. You know, it's nuanced around when you adopt these things. But I certainly think it's positive steps forward in the data space.
And I think just for time, we need to keep moving, but I did put a link in the chat if folks want to read Zhamak's original article on data mesh, and maybe we'll have time for questions later on that.
Sounds good.
So we keep moving, yeah.
Sure. This one again, I was really fascinated about this decentralized identity conversation when it happened during the radar, because to me, this is another kind of enabling piece towards this decentralization, right? I actually didn't know about it. So what is decentralized identity? If you think about kind of identity management, right, in a general form, it has remained a centralized piece of any architecture. Identity management might be, you know, managing the identity of people or your workloads within the organization, and you have some sort of an active directory or some sort of a directory, or it could be, you know, the identity of the domain. So there's centralized domain registries, or, you know, identity of your kind of services and domains through certification providers. So these are part of the identity management infrastructure that are very identity providers have been very centralized, despite like all of the decentralization that we've seen, right? Microservices, data mesh, or whatever. What decentralized identity as a technique kind of suggests is that now we can provide, actually, we can in a self-sovereign way, those entities, whether it's organization, people, or things, they can create and own their own identity. And there is this distributed ledger-based, you know, distributed public key infrastructure in place to allow to create these globally unique identities, to cryptographically validate them, and that in that kind of self-sovereign way own them. And each of these identities can be resolvable to some sort of a metadata, right? It's a profile of the person or company or whatever that kind of metadata can be. So I think it's a really fascinating technique. To be honest, it's unassessed because we didn't have a whole lot of experience with it to give you practical advice. And usually, I mean, James and I can talk to this, but when we think about the beliefs that we want to include, we often try to be very specific with our advice and really kind of come from practice. But this has grabbed our attention when we started thinking about it. If you want to know more about it, I think there are a few places you can go to. There is the Decentralized Identity Foundation, which is an industry kind of collaboration with Microsoft and a few other people. There's a W3C draft of decentralized identifiers, which is talking about kind of the standardization around it. And it looks like out of all the providers, for some reason, Microsoft has led the way and created some kind of basic identity hub infrastructure that's worth looking into. And I think we can all think about great use cases for this, right? Just think about healthcare. I know that healthcare, at least in North America and probably other countries, is going through some sort of an evolution to become very data-driven. You know, the holy grail of, you know, the healthcare and data is this longitudinal health record where every person can see all of the touch points that essentially they've had with the healthcare system. And when you think about that, who owns the identity, you know, who owns and creates the identity of the patient, right? Which provider? It should be the patients, it should be the people themselves, and then infrastructure allowing to kind of control that identity along the way. So I think it was really fascinating, and it's just another enabling piece towards decentralization.
I'll actually, I mean, give another example here. I mean, it's very relevant in the UK at the moment, where there's a huge scandal around contact tracing and the apps that are going to be developed or that are being developed to do contact tracing, because the UK government have chosen to go for a centralized mechanism to do contact tracing, as opposed to Apple and Google, who, you know, Android and iPhone have decided to go for a decentralized, you know, approach to it. So I think this is only going to become more important, and it is highly relevant just at the moment as well.
Okay, and moving along, I think we'll keep moving. And if you do have questions, there's a sort of a specific question, throw them in the Q&A. I'm seeing some chat in the chat, which is great as well. That's kind of more, you know, attendees talking to each other and sharing links and stuff like that, that's totally cool. But if you have a specific question, throw it in the Q&A section.
All right, so under that sub-theme of scale, I think Apache Pulsar was another platform worth mentioning. Again, this one is also an assess, even though this is not a new technology. Pulsar is a kind of a pops-up messaging streaming platform, very much like Kafka. It competes in the same space, and it's been open sourced by Yahoo since 2016. So it's been around for a while, but and as you can imagine, it has all the features that you expect from kind of a messaging platform. It does sync messaging, async messaging. It does persistent. It does tiered storage for kind of long-term storage of your kind of messages and events. But the reason it grabbed our attention and we started kind of assessing it is this ability for it to scale, right? So when we think about scaling architecture within the organization, we care about an architecture or infrastructure that can be upgraded easily. It can be segmented for different users in the organization. You know, you can have separate event billing structure around the segmentation of the user. So Pulsar does that pretty well. You know, if you're thinking about, I want to roll out, you know, a messaging infrastructure to a larger organization with a lot of subgroups using and having different patterns and different upgrade kind of schedules. So this Pulsar might be worth looking into. The particular reason that we looked into it was, again, in support of data mesh, because we want to have kind of this distributed ownership of data and different access to these kind of decentralized data sets. And one of those access patterns is through kind of event-driven and streaming access, and that's not the only one. And Pulsar said that kind of idea of having this infinite log of messages or infinite log of kind of events being accessed by Pulsar, being used by Pulsar was an interesting one. So we're still assessing this. We will report more on the next radar, but some of the early challenges or kind of things that you want to think about is that as part of its installation, this comes with Zookeeper and Bookkeeper and a few components that you've got to manage, and its adoption is growing. So if you compare its GitHub watches and stars, it's compared to Kafka is still a bit lower. So if you run into problems, you probably don't have the same, you know, the community that you get with Kafka. But it's exciting, and we hope to report more on this.
Hey, we had an interesting question here on the sort of the data front. This one's from Bjorn. So they say, in Asia, your personal data is typically owned by governments. In the USA, your personal data is owned by large corporations. And in Europe, your personal data is owned by you because of GDPR. Do you see this impacting the use of different technologies? And do you have any thoughts on how that will impact competition?
Yeah, I can start, and I hope Joyce can kind of chip in as well. I think there are two parts to it, right? When we talk about identity, this, you know, we went from very centralized identity to federated identity, and now we're talking about decentralized identity. So it's a progression that is happening. And what constitutes identity, right? It's a big kind of philosophical question. The thing that I see decentralized identity as a first step try to address is the ownership of your identifiers, right? How do you how do you own your identity and the identifier that really points to who you are across different systems, whether you Google or Facebook and so on? And I do acknowledge that if we look at identity as just aggregation of our attributes and aggregation of our behavior and all the breadcrumbs that we've left on internet as we live our daily life in this digital world, that one interpretation of identity, and you're right, that identity, Google probably knows a lot more about me and what I prefer, or Amazon knows what I read that I have a self-awareness of, and we're not yet solving that. But what decentralized identity is trying to solve is that you at least have one lever, one place to control all of these pieces of information about you that are scattered and owned by different organizations, and that's your identifier. And then that's I think is going to have an impact in how those organizations that are competing keeping your information would work with you, right? Because now you own that identifier to keep or not keep, or apply different regulatory kind of requirements around it. Of course, I'm just looking at crystal ball. I have no idea really. That's kind of a wishful thinking.
I mean, I can't speak specifically to the decentralized identity piece, but I do remember we often have conversations in the radar group, face to face, with our colleagues from Germany, who do definitely talk about how different tool choices are essentially forced on them by German law. Not forced on them, but certain providers are preferred more than others. So Microsoft, for example, I think is preferred in some cases over some of the other providers in Germany, purely because of the notion that they insist they won't bow to US government pressure to open data to the government. So I mean, I think there are tool choices that you do have to limit tool choices depending on jurisdiction that you're in. But in terms of decentralized identity, yeah. Mike?
Cool. Okay, we'll keep moving. We got a few more on the data theme, and then we have a different theme to talk about as well.
All right. Did we skip over one, or this is the next one?
No, I think this is the next one.
Okay. All right. So the other, I guess, sub theme within kind of this big mega theme of data evolution is essentially thinking about machine learning and analytical kind of systems or machine learning models as software, and really bringing the practices that we once applied to software application development to machine learning. And one of these is continuous delivery, right? So CD4ML has been on the radar, and it's going to reappear here, and it's in trial, which is basically become the de facto way of us building machine learning. And if you think about the value stream of a data scientist workflow, right? How do they go from discovering the data that they want to use to do feature design, to train their models, to kind of validate their models and see the errors and tune and finally publish something that is serving an API or producing a bunch of data to be used in some form of, whether it's a prediction or whatever kind of optimization we're doing for our business, and then monitoring it and then improving it. So if you think about that value stream, right now that value stream fairly kind of segmented. You've got the data engineers working up front, getting the data. You've got the data scientists in the lab doing its work, and then you've got these ML engineers doing the productionization. And continuous delivery really tries to remove all of those manual handoffs in between, automate the process as much as possible with the tooling, and remove friction, and get to the point that a machine learning model can be deployable or releasable at any point in time, right? And if you think about the pillars of that support continuous delivery in software or application, it's the same thing for machine learning. Maybe the flavor of tooling is slightly different. So as part of those pillars, source control. So we have to have a repeatable process. And here, the source control not only applies to your artifacts, which is like, serialized version of your model, but also the data that trained that model, right, to get that repeatability. So we've got a bunch of tools like DVC around, or MLflow tooling that kind of supports that versioning and repeatability of the experience. There is all of the CI/CD pipelines, because you need something to manage the automation of deployment. Environment provisioning, and for machine learning maybe it's more interesting because at any point in time probably have various experiments running in the environments, various models that you are kind of tracking and tracing. And one of the observations that we had was that when I put the question to kind of our data scientists, that, okay, give me your favorite tool that you use for machine learning. And it was like, I didn't expect the response that I got. It was like, go away, because there's no one tool. There are like so many different, it's like asking people, what is your favorite tool doing web development, right? So there's a very large space of tooling. And if you're on a particular cloud provider, they probably provide you a bunch of tooling around kind of versioning and repeatability and tracking and tracing of your models. But it's a super fascinating space, and it's continuously kind of evolving. So we thought we should share some new experience on it.
Awesome. And then I think we've got a couple more tools to cover, and then we can move to our second theme.
Yeah. So on the on this kind of I guess sub theme of bringing more tooling in support of the delivery and build and delivery of machine learning, Manifold is one of those tools that allow you to kind of visually debug your models by looking at your kind of various training data sets. So I think we had facets in the past, or maybe we didn't, I can't remember. Facet was another one that it kind of looks at the data. And this is an open source tool, came from Uber, and they're using it for, estimated time of arrival. Well, whenever it was that we were taking Uber, I don't know if we are now, but they were using it to do estimated time of arrival. And really it recognizes that 80-20 rule, right? That the 20% of the data scientist time goes into creating that first working model, and then the other 80% is like, okay, let's tune it and retrain it and looking at the data. So this is a nice visualization of kind of the segments in the data. It looks at which part of your data you've got good predictions and which parts you had large errors, and gives you kind of visual ability to kind of retrain and analyze your data and spend the other 80% of your time. And we're seeing it being a very useful tool in kind of the ecosystem if you're building machine learning models.
Excellent. And I think the last one for this section, yeah. That's
right. It's the last one. It's actually an odd one. So I thought maybe we get some good things and not so good things, like controversial things to talk about this. So the third sub theme is really around lowering the bar, right? lowering the barrier to entry when you use machine learning, right? Once upon a time, and maybe it's still true for many organizations, that you've got this kind of ambitious plans is how the machine learning would be used in all of your organization, but you have this data scientist in a corner somewhere, and they're working on a couple of problems to solve. Whether you're in retail, and I'm sorry if you're in retail and you're suffering right now, but if you were in retail and you're trying to kind of dispatch your I don't know, clothes to your shops or to your dispatch centers, and you want to optimize the route, so you want to make recommendations. So these are the problems that traditionally we used machine learning for, but these solutions were very much isolated to a group of people that had really strong statistical and kind of data science background, and then if you think about how the pipeline would put in place to support this group, is that data is somewhere in a lake or maybe in a mesh or warehouse, and you've got all of this pipelining to get the data to the data scientists so that they can use it and retrain it. BigQuery is a data warehouse, right? It's a data warehouse on GCP. It can run really large scale, maybe not so fast, but large scale SQL queries across tons of data and tables. And what they've done is that they say, essentially, instead of getting the data to the data scientist, let's get to the model, let's bring the model to the data. So at first, when you look at it, it's a little bit odd. So we had actually two camps of thought workers around this, like one camp that is super excited at how easy it is now to kind of explore or experiment with machine learning within data. And the other camp kind of raising eyebrows, and we'll talk about that in a minute. So essentially, BigQuery says, okay, you're already in the warehouse, you're already making queries, and you're already using SQL to get this data out. Why don't we extend that SQL language that now you can automatically, out of the box, create a bunch of models, and they support out of the box a few kind of type of models. They use, they support linear regression for forecasting, or binary multi-class regression for classification, and they also allow you to import your TensorFlow with some models for some limitation. But essentially, you can create one of these models with SQL query. You can train them, right, getting data out of the warehouse, and just in the context of BigQuery, train that model, validate it, see the errors, retrain it, design your features maybe differently, and essentially then run it and make predictions. And all of that within the context of BigQuery and SQL. So I think that's the group that we're very excited about it, because it really enables quick exploration, right, and experiments. And the group of us that were a little bit kind of concerned is that, okay, it's great that we are lowering the bar, but what does that mean in terms of that level of expertise and awareness and the tooling that is required to implement continuous delivery, right, for machine learning that we talked about, to do testing, to do ethical bias testing. Are we going to skip a whole bunch of intentional and maybe slightly time-consuming practices that needs to go around testing of these models, and particularly bias testing? Now we're lowering the bar, and you can just run a SQL query and you have a machine learning model. So it's an interesting one to experiment with and explore, and then see what the limitations are with cautious.
Excellent. So what we're going to do, we're going to jump on to our second theme, which is one so the themes come up when we get to the end of our radar discussions and try to figure out how to make sense of everything that we had discussed. And part of the reason for doing that is because the radar has 100 different blips on it, and so there's some, you know, that's kind of overwhelming to try to understand that. So the next theme was X is software too, and I think this is, to me, this is one of the interesting trends that has happened in the IT industry over the last decade as the radar has evolved. And I'm going to throw it over to James to talk about.
Yeah, I think you're right, Mike, and it's interesting because I think this theme, X is software too, it's almost emerged as a meta theme over the last 2 or 3 editions, I'd sort of say, where we start talking about things like as code, compliance as code, we talk about governance as code, security as code, lots of different things. So what we're really doing is calling out that there's a whole bunch of techniques now that are falling under the purview of what really should be sort of software and software engineering. And we should be treating these new things falling under that purview as actual software, as code. So the first thing we're going to talk about is apply. Oh, I should point out that's not just as in we should, you know, as in infrastructure as code, we should declaratively configure our infrastructure and so on. It's we should treat this code as we would the code that's running in our software system. So it should be tested and it should be testable. It should be easily deployable. It should be source controlled. We should apply the same engineering discipline, you know, in terms of things like single responsibility principle, the solid principles, dry, etc., etc., to all these different things I'll be talking about. So, so the first one is the technique of applying product management to internal platforms. Now, we've re-blipped this time because we think this is still really important. Actually, you could probably argue that a lot of the things we'll be talking about are just the tab, you know, the radar group members like shouting at clouds because we're angry at people that people aren't listening to us. But we've re-blipped this because we do think it's important, because what we're seeing again and again is organizations deciding that they're going to build an internal platform for their developers to use, you know, on which software can be run, but building it up front, building it sort of first, you know, with hope that people will be attracted to it and use it. And often what we see is these are big white elephants, essentially. These platforms turn into you know, complex platforms that people don't really like using, and so they don't get the amount of traction, and they don't actually deliver the benefits, which in terms of flow efficiency to development teams, that they should do. So what we're saying with this is you should apply the same sort of product management techniques and you know, to platform teams as you do to any other team building any other bit of software in your organization. So that's product ownership, that's taking care of good UX, that's doing customer research, that's again applying all these different, you know, testing, continuous delivery, all these things to product development of platforms. So in order to get the benefits, and don't just build, you know, a big horizontal slice of platform and expect everyone to use it. Instead, build vertical slices, thin slices through your platform, engaging with the people who are going to be using it at every single stage. Have I missed anything out there, Jamak and Mike? You got anything to contribute?
No, I think what I see over and over again is that, you know, we talk about this platform being a product, but then how we go about implementing it is anything but building a product, right? We talked about building a platform without a customer, or building a platform for very specific point use cases as a point solution, and it's striking that balance between the two, as in a platform that has a substantial internal market, happy customers, is actually really, really hard. I mean, it requires intentional assignment of people with that experience to that project, right? It's not good enough to just have an architect. You actually need a technical product owner or platform product owner that's bringing those platform kind of product thinking principles in action. So it's an easy set and really hard to do, I think, area.
I mean, we had a question in chat about whether anybody actually understands product management techniques, and I would say that a product owner, and especially for a platform, a technical product owner, is one of the hardest jobs in the industry, and it's not to be underestimated. The skills and learning path that someone will need to go on in order to be successful at that.
Yeah, I mean, I'm consistently amazed by how the product owners product managers and product strategists that we've got in Thoughtworks, I'm consistently amazed at how they think differently to me. You know, they are a very different type of individual with a very different skill set that I simply don't have. And if I was an architect on a platform team, you know, I wouldn't necessarily know the first thing about where to go to get started with customer research and things like this. You know, user research and value, yeah, all the sort of stuff that they think about that is just pulls out of the top of my head. Anyway, moving on to the next one.
So the next one, James, just as a data point for you, I don't know whether you already know this. I was writing about it for an article that goes with the radar. We first blipped this on the radar in 2011. So not new. Why are we bringing this one back, James?
Yeah, well, I mean, again, I think it's because, thanks, Mike. I think it's because, yet again, you know, we're shouting at the clouds a bit because we're continuing to see infrastructure not managed as code, and also additionally, as new tools and new platforms are becoming available, we're continuing to see these managed in kind of flaky, snowflakey kind of ways. So things like K8, things like Kubernetes, Docker, you know, they have all been developed since actually we blipped this on the radar initially. And you know, whilst we've seen some progress in tooling around these around infrastructure as code, things like Ansible, I think we're still missing key abstractions. We're still operating at a fairly low level in terms of infrastructure as code, and we're still looking for the high level abstractions to become available. But we're re-blipping it because we think it's super important.
Yeah, and I think when we talk about as code, right, we immediately think about all of the coding practices in terms of the last mile, have it in source control and then test it and then, you know, deploy it in a predictable fashion. But I think there's another aspect to this, is that the design and kind of the design principles that we apply to software, like modularity and abstraction and solid principles, we often forget about those when it comes to writing a bunch of, you know, Terraform scripts. So I think it's another angle of as code that we wanted to really emphasize here.
Well, and even things like, you know, good naming, stuff that's easy to work on, that a team can work on, and not just one magic individual in the corner who knows how to manage all the infrastructure scripts. You know, all of those things around, when we say as code, we really do mean that in a very sort of holistic way. All of the good stuff. I think one of the storylines of the radar is us calling out good ways to do things, and then a new tool coming along and people forgetting all of the good engineering practices in general from the software world, or failing to apply those enough in a new context. I think even when you come to kind of, you know, because software people are getting closer to hardware people, and sometimes the lines between software and hardware are starting to get blurry. And a lot of the things that we know from how to do software well now also apply much more in the hardware world, you know, because it's increasingly malleable and software driven. Yeah,
and I think it's. And it goes in cycles. You're right, Mike. Right. I think this is one of the big things I've sort of noticed over the last decade or so of the radar is you'll get a new thing happening. Like suddenly machine learning becomes a real thing, and then you get this cycle of like productionizing approaches to machine learning. So we had CD for ML earlier. We've got just version control systems for machine learning. We've got data provenance tools for machine learning now. It's all the sort of things that we'd expect to do if it was a build pipeline, which we were running, features through. and then the next thing will happen. And I think, I think that cycle will continue. So infrastructure is a thing. I think security again is a thing. I think we had that on there as well. And things like architecture, you could even argue that we're getting to the point now with architectural fitness functions, which you can define in code and execute as part of a build pipeline, that you're starting to talk about, software architecture as code as well, which means we can actually start to apply all those things to the idea of evolutionary architecture as well. We can version control our fitness functions. We can version control how the shape of our software should be over time.
Speaking of pipelines, the next one.
Also a reblip in adopt, which is pipelines as code. So again, this has been on the radar several times previously. But what we're really saying with pipelines as code is, as we move towards more decentralized, creating decentralized software, so distributed systems composed of many services, small or large, and we're talking about things like data meshes and architectural styles like that, then it becomes even more important to start defining how your software is built and as code, and having it live with the software that it's building. So we've had lots of good success with things like pipeline templates. Many of the tools actually now support templating and actually having code pipelines next to your applications themselves. So yeah, we're re-blipping this in adopt on the basis that we still think this is super important and a very valuable technique. But again, as Mike sort of pointed out, and Jean-Marc pointed out, this is not just about the what the language or the templating language you use to create these things. It's also about managing them as managing them with good modularity, good boundaries, and all these kinds of things as well.
There's a little question here. Shouldn't we avoid hard coding pipelines? What do you mean? Can you clarify?
Oh, I missed that. Scroll down.
That's all right.
Hard coding pipelines, if I understand it correctly, it means you're kind of hard coding all of the instructions or declarations that goes into definition of the pipeline. What is the opposite of hard coding is allowing for configurability, if I understand it. So we're definitely not suggesting hard coding, we're just suggesting coding
Yes.
in your pipeline. And I think what James is talking about is that, when you have multiple teams that are building different applications and they have a pipeline configuration, right? That this is how I'm going to test this and how I'm going to deploy this. You really want to have a common way of deploying the applications. You don't want to have 5 different ways of deploying applications, right? So you end up abstracting some of these codes that it gets applied to various stages of your pipeline. So as you abstract those, you're building libraries, you're building kind of templates that can evoke those libraries and can, in a consistent or standardized way, run some of those pipelines. But at the same time, code allows you to have a bit of variability as well, right? Standardize some things and be variable in other ways. So that's just coding and not hard coding.
And then another one, what's this? This is hold. So again,
Yes.
Not new, but we're seeing a lot of this right now. Cloud lift and shift.
Yeah. So we're calling this is strong advice from us to say hold something. So so cloud lift and shift, and this is just taking what you've got in your data center, and it used to be the case that you just take what you've got in your data center and deploy it onto whatever EC2 instances or whatever in whichever vendor other cloud platforms are available. Just essentially taking what you have in your data center and dropping it into the cloud and expecting everything to work okay. What we sort of advised at the time, so this quite a few years ago now, and in fact originally what the cloud providers were advising themselves was you need to think differently about software architecture for the cloud. And in fact, you shouldn't just pick something up and drop it there. Of course, there's revenue streams, giant revenue streams now available for these cloud providers to just pick stuff up from your data center and drop it into the cloud, right? So a lot of their offerings, well, there are several offerings now around this, even things like HANA and things. but also this is also the infrastructure ecosystem has evolved. Again, I mentioned Kubernetes and Docker earlier, and we've had quite a few examples now of clients who are doing the same, except with containerizing their applications, dropping them into Kubernetes, and expecting everything to work. Now, well, either expecting everything to work or recreating the old sort of ops anti-patterns of throwing containers over the fence to the people running the Kubernetes infrastructure. So I guess our advice here is, you really need to think about whether the software that you've got running in your data center is amenable to be run or scheduled on a set of boxes that might just randomly disappear. For example, not all databases are kind of going to be happy if you just start moving instances around and things. For example, many older stateful systems are also going to be in a bit of trouble when you start dropping them into infrastructure like Kubernetes. So think very carefully about the architecture of your systems before thinking about just dropping them into insert your cloud vendor as infrastructure here. That's really the advice here.
And just as a fun data point on that one, I saw a success email from our internal tech ops group that Thoughtworks has finally fully moved to cloud.
Yes.
Although some of those systems are lift and shifted, but we have not done it without thinking about it carefully, and it was only a few systems that have not been fully redesigned for cloud.
Yeah, I mean, 15-year-old version of PeopleSoft. No, I'm joking.
Right, whatever it is. Yeah, yeah.
And I think that was a good point that Keith Morris made when he was reviewing the write-up for this book, that, and he's the author of Infrastructure as Code book, which was like, it's okay. Like sometimes you do have to lift and shift, like the reality of deadlines and data centers, contracts being terminated, and all of those are real. But what is important is, as part of that migration process, you build the foundation for continuously evolving the systems beyond the migration, beyond the point of migration. So having your CI/CD pipelines and automation in place that maybe during, before, or after migration, you're continuously evolving your architecture system towards that cloud native state.
There's a question here. Do you see a trend back to on-premise with cloud technologies, that you can run yourself, and especially with concerns about regulation and all that kind of thing? I'm seeing some nodding here, yes?
Sorry, go ahead, James.
No, please, I'll teach you about.
Yeah, I think what we definitely see is that people are getting more concerned or aware of the options that they have beyond just like whole of state migration of everything to one cloud provider, right? They're becoming, okay, actually a bit more intentional. So we had projects in Australia that were kind of cloud migration in a very highly regulated environments. We actually had a podcast on that one, that organizations think about their states and their assets, and based on the risk profile and based on the level of controls that they want to have, pick and choose where they're going to run various workloads, which then lead to, okay, a bunch of these things going to run on my on-prem infrastructure, and that leads to which of these cloud providers kind of managed services can I run internally, right? Am I going to use Anthos or whatever equivalent of that the AWS and kind of Azure provide to reduce, while to get the benefits of cloud, which is like reduce operational costs, but have the control of running my workload locally. So we definitely see a sophistication in the multi-cloud or poly-cloud deployments, and on-prem is a component of that sophisticated environment. We definitely see a desire to still reduce the cost of operation by using the cloud providers like control plane in a sense to run locally, and I think that's a good trend, right? That completely shifts and changes the landscape of competition between the cloud providers to be a little bit more cooperative with other pieces of infrastructure that are not owned and managed by themselves.
Yeah, I mean, just finally on that, and I think it's actually it's a specific play by some of the cloud providers to do that. They're actually offering products now that will act. They'll sell you a data plane which will work across VMs, bare metal, Docker containers in your local data center. When you're running your own Kubernetes, plus also other cloud providers. So I think there'll definitely be movement in this space. I mean, you know, if they're seeing it as a revenue stream, there must be significant opportunity for them to invest in it. These folks are pretty good at doing that. So, I guess we should move on to the final one.
Yep.
Which again is related in some ways to what Zhamak was saying earlier. So this is declarative data pipeline definition. You know, I wouldn't consider myself to be an expert on data engineering at all, but we do have a number of people as part of our group who are absolutely, like, well, just amazing experts in this field. And what they sort of talk about, and what our teams talk about, is how often, you know, configuring data pipelines to do, you know, the transforms, basically, you know, sort of modern ETL stuff, really, to get data into a position where it can be used by data scientists or analytics tools or whatever, is generally a big crufty either Python script. There's a bit of Bash in there. There's going to be all this kind of you know, great languages. Don't get me wrong. I love a bit of Bash. But really, you know, what would be nice is if we could start to move towards, like we have done with infrastructure as code, towards a sort of declarative approach to defining data pipelines. And there are starting to be tools becoming available now. There's one actually by a friend of Thoughtworks, a guy called Tommy Hall, called a la mode, and that's kind of an interesting tool, because what that does is it's a declarative approach to it's a bit like Airflow actually, but it sort of builds on top of that model to give you the ability to only rerun parts of your pipelines based on data changes. So something to look out for. But yeah, this is another area where we'd like to call out as, you know, the data pipelines are also code, if you like. Data pipelines is software too.
Everything is software too. Okay, and we just got a couple of minutes left. So I'm going to wind up with a couple of questions about using the radar. So a couple of people have said, you know, how do you use the radar? Can we build our own radar? Like, what do we do with this thing?
Yeah, I mean, those are great questions we get. God, I sound like a certain individual. Great questions, the best questions. Yeah, I mean, we do this a lot. This is actually something that we offer, either help with facilitation. So, you know, whichever country you're in, you could reach out to your local Thoughtworks office, or even to one of us on this call, and we can help put you in touch with people. In general, we run an exercise called Build Your Own Radar. When we do it, it's over the course of a week. You know, every 6 months. So, you know, we invest a lot of time in it, but that's because there's, you know, what, 7,500 thought workers working on hundreds of projects around the world. So we get so many data points, things to include. I think it's like 300 plus new items every 6 months to consider for inclusion. What I normally say, and other advice may vary from Zhamak and Mike, is, you know, if you do want to invest in creating your own radar, I would suggest probably spending a half a day at least on the exercise. And my big tip, which I got from our colleague Neil Ford, is to try and get all the different roles or different grades in a room. So don't just have all the architects do it. Don't just have all the developers do it. Make sure, you know, try and get CTO, architects, developers, all the roles that you have in your organization, because it really facilitates conversation across what can be sometimes, you know, quite firm silos, organizational silos, and that's a huge benefit. I know of quite a few other companies that do this. Redgate build their own radar. They talk about that on their website. The database tools people, Spotify do it internally. We're talking with them at the moment because they're publishing an open source tool in this space, which is kind of interesting. And there's another company called Zalando that also have some tooling around this. But if you go to our website, the canonical version, of course, you can download from our website or from our GitHub repo, actually. So yeah, go to Thoughtworks website and download the tool. God, that was a long explanation. Yes, we can help.
No, it's a good explanation. I mean, I think the biggest thing is getting all the people in the room and a virtual room these days, and using the radar metaphor as a way to get through some of the difficult discussions about tool and technology choices. Okay, so we're at the top of the hour, at the end of our time. Thank you very much for tuning in, and do look out for the radar and all the associated stuff that goes with it next week. I would like to say thank you very much to Zhamak and James for their time today presenting.
Thank you.
Thanks, Mike. Cheers.
Thanks, everybody.
Bye-bye.